So today we are going to talk about algebraic calculations. For example, if we have certain equation, say 2x minus 6 is equal to 0, we know the solution is x should be 3. This is I'm just typing it for example. You cannot write it on in front of fx. So if this is an equation, how you are going to solve it? So for that you need to make a vector first. Let us make a vector called EQ for equation, and we have coefficient of x as 2, give it 2, and constant is minus 6, or you can give minus 6. This is minus 6, or rather you have to give 6, because this is how it is going to be solved. And what function which you are going to use is important. This is, please pay attention, this is the most important thing. You have to use roots, and in these roots you pass EQ, and as expected your result will be minus 3. And as I was telling you that if you go for minus 6, your result will be 3. Again, let me run for it. Roots equation, this is 3. Okay, now let me go a step ahead or further. This is my function x square minus 16. How I am going to solve it? We have exponent of x square, we don't have exponent of x, there is no x value, and we have minus 16 here. So for that I have to make the equation something like this. Equation is equal to first x square exponent, that coefficient, that is 1, and I don't have x value. For that we have 0, and minus 16 is constant. This is I have made 16, and I just need to make a simple function, that is roots, and IQ should be passed inside it, and we have answer as 4 and minus 4. What if I have an equation of this type? Because we know that the solution is not there, it has to be an imaginary solution. So roots function will give a solution for that also. How? First make equation. Let's just change minus 16 to plus 16, and again run that roots, and we see that we have the solution as imaginary solution. This is what we would have expected. Now let's go to a bigger equation, say fifth root equation, that is x to the power 5 minus 3 x to the 4 plus x minus 12. For that again we have to make a vector first, that is EQ is equal to, we have 1, all coefficients whether positive or negative, minus 3, then 0, then 0, then 1, then minus 12, and let's see what will be the solution, that is calling function roots with passing parameters EQ. So this is the imaginary solution we have. Okay, now we need to solve linear equations. How we are going to solve linear equation? If I have one equation, say x plus 2y is equal to 4, we have x and y as variable, and I have another equation, say 3x plus 4y is equal to 5. I want to solve these two equations for x and y. How to solve it? We have to make a matrix first. The matrix as 1, 2 first row, 3, 4 second row, and another matrix with 4 and 5 in one column. So let's make a matrix. A is equal to, as I said, coefficient of x and y in first equation, that is 1 and 2 in semicolon, because the next one we want on next row. So 3 and 4. This is okay. Make B also. B is equal to one column, 4 and 5. So 4, and for second column we need to place a semicolon sign, then 5. Okay, A and B has been made. Let me make it B again, so that it should be bigger one. Just because you might have seen in books, I just want that it should be like that only. A and B has been made. And how to find out the values? Say some variable SOL, and what we have to do is find inverse of A, and then just multiply it by B. Done. X is -3, Y is 3.5. Any other method? Yes. A inverse into B. And how to find out A inverse? Make it A and inverse, give a cap, -1, and then multiply it by B. This is A inverse, this is B, similar to this. Again the same result, -3, 3.5. Now is there any other method? Yes, we have. A divided by B. This is backslash basically. A by B, same result. Is there any other method to find out the linear equation? Yes, we have a function called linsolve. LINSOLVE. Pass A and B. There are 4 methods. I've given you 4 methods in Matlab to solve systems of linear equations. Again, the same solution. So, thank you so much. Take care of yourself.